Energy conservation, or the efficient use of energy, is becoming one of the fastest growing industries in the nation today. The demand for more energy efficient homes has brought about the development of sophisticated equipment for locating and measuring leakage areas in homes. Air infiltration accounts for up to 40% of the total energy required for residential heating and cooling, making it the single greatest energy conservation problem. The energy door was developed to determine where these leakage areas are and to implement a sealing program to solve the problem. Let's take a look at the energy door in operation and view its many features. The 6 metal casters on the front side make for easy loading and unloading into a van or pickup. 10-inch all-terrain inflatable tires along with carrying handles create a dolly effect for wheeling the instrument to an exterior door jamb. The wheels also permit easy maneuvering over any kind of surface directly to the exterior door. Once the instrument is in place, the latch at the top of the door is released, and the 2 spring-loaded mechanisms push the height adjustment into place. The holding lever on the height adjustment is then pushed in and engaged to hold the instrument in the door jamb. To complete the setup from the outside, the 2 latches on the side adjustment panel are released, and the 2 spring mechanisms slide the panel into place. The outside setup is complete. We now go in the home and finish setting up. The slide adjustment is moved to the left and the wing nuts are tightened. The instrumentation is placed on the tripod and the wires from both the RPM digital tachometer and the variable speed control are plugged into the energy door. The next step is to insert the metal tube on one end of the plastic tubing into the hole on the door, and then attach the opposite end to the pressure tap on the manometer gauge. This gives us outside air. Attach the second plastic tubing to the other pressure tap. This gives us inside air. The weather cover is removed when the instrument is in use. The energy door and instrumentation is now completely set up. This is the on-off switch. It also controls the direction of the fan for both positive and negative pressure. The variable speed control knob controls the speed of the fan. The manometer or pressure gauge enables us to determine the pressure drop between the inside and the outside of the building shell once the fan is turned on. The digital RPM tachometer gives us the exact fan speed. The fan pulley is attached to the motor pulley using a non-slip belt. The tachometer is attached to a magnetic transducer on the motor to pick up an electrical impulse on each revolution of the fan. The reason for this setup is to have the capability to determine the amount of induced air changes per hour. Every home has a rate that it loses energy due to air infiltration, and that rate is called air changes per hour. The energy door is calibrated so that we can establish this rate. Before we turn the instrument on, let me show you how we detect the leakage areas when the home is under pressure. We induce approximately a 15-mile-per-hour wind into the home, and using this smoke gun, we squirt the smoke. With the home being under pressure, the smoke is instantly drawn to the outside. This totally eliminates all guesswork as to where air infiltration occurs. There are more than 20 leakage areas in a home. Let's turn on the energy door and take a look at some of these areas. The first leakage area is commonly known as the exterior sole plate. This area is the #1 leakage area, accounting for up to 25% of the total air infiltration of the home. The 3 accepted methods for sealing this area in the past do not stop air infiltration. Wall sockets and light switches are the #2 area, accounting for up to 20%. Another area of air infiltration is where the plumbing penetrates the sheetrock. Leakage also occurs around fireplaces where the sheetrock or paneling meets the brick. The energy door is an excellent instrument for both locating and measuring energy loss attributed to air infiltration. It is one thing to tell a homeowner or prospective home buyer where a home is losing energy, but to show them visually and tell them what can be or has been done is a tremendous marketing tool. The attitudes of homeowners and prospective home buyers are changing. By the most conservative estimates, utility costs will increase by 10% per year through the 90s. The efficient use of energy and energy-efficient homes are here to stay.